Okay, today we are talking about 4.6a, which is going to be the first part of linear inequalities in one variable. We're actually just going to work with the first two objectives. So we're going to graph the subsets and we're going to solve linear inequalities and graph them as well. So, to refresh your memory, because I know you have all done this before, remember that an inequality, what is an inequality? It's when you see something that looks like that, which is your greater than, or that, which is your less than symbol. An inequality means that there will be shading in your graph. Now, we're talking about one variable. So in one variable inequalities, all of our graphing will be on a number line. So we'll talk about that more as we get there. The other thing that's important, when you have your inequality symbol, you will either have greater than or less than symbol, or you will have greater than or equal to or less than or equal to. If you have greater than or less than, then when you do your shading, you're going to have a circle on the number line, and that circle will be open or hollow, however you choose to remember it. And if it says greater than or equal to, less than or equal to, then your circle will be closed. So when I do this, I think of an extra symbol here. It means extra work, and I got to close in that circle when I'm actually doing my graphing. And we'll talk about that as we go through. The other thing that's really important to remember when you're working with inequalities, if you, I don't want to start off with that, if you multiply or divide by a negative number, you must flip the inequality symbol. Okay, so we'll be going through that. Only if you multiply or divide. Doesn't have anything to do with your answer being negative, just whether you multiply or divide by that negative number. So I give you a chart with all of them in there. Here's A is less than. Okay, it's no equal to, so we have a hollow dot. This is less than or equal to, so we have a solid dot, and that goes through. The other thing that you can remember that will make your shading easier is if when you solve yours, your variable is on the left side of the equation, then the arrow, the inequality symbol, excuse me, will point to the way you shade. This points left, you will shade left. Okay, we have some compound inequalities that we're going to talk about also. Okay, you have to pay attention to what is on each symbol. So the A would be a closed dot, and the B would be an open dot, which is what they have here. And whenever you see these compound inequalities, that's when you graph those two numbers and you're going to be shading in between those numbers. Okay, so let's do some examples. Your first set of problems, graph each set of real numbers on the number line, and then this next group is solving them also. So x is greater than negative 2. When you graph for me, what I care most about is, first of all, putting 0 on there somewhere. Okay, I've already put the arrows on for you. Tell me where negative 2 is. I don't care if you put all the tick marks, just tell me where the negative 2 is on the left or the right of 0. So hopefully everybody knows it's on the left. So negative 2 is my number, which means I'm going to circle that number. Because it is not equal to, I'm not going to shade it in. And as we said, if the variable's on the left side, then this points to the way you shade. So I'm going to shade this way. And I like to do a little squiggly, and I kind of missed the line, and then draw the arrow because that makes it different from the number line and makes it easier for me to tell what the answer is. Okay, let's look at the next one. This one says basically negative 3 is less than or equal to x, which is less than 7. But it might be easier to remember that x has to be between negative 3 and 7. So I'm going to put 0 down. I have negative 3 on the left side, 7 on the right side. It is further, but it doesn't have to be exact. But these are my key points. So this is where I'm going to put my circles. My negative 3 has an equal sign, so I'm going to do the extra work. My 7 does not, and I'm always going to shade in between when I have this compound inequality. Okay? Let's look at number 48. We actually have to solve this time. So I'm going to solve x over 4 is less than negative 1. It's dividing, so I'm going to multiply both sides by 4. I did not multiply by a negative number, so I don't have to flip anything. But my 4's cancel. 4x over 4 gives me just x. That stays the same, and negative 1 times 4 is negative 4. So that is the algebraic solution, and I have to graph it. So again, I'm going to put 0, and I'm going to put negative 4. I'm going to put a circle on it. It does not have equals. I'm not going to shade it in. And I go, the arrow points to the left since x is on the left. So I'm going to shade that way. And I'm going to make an arrow bigger so that you're letting me know you know it goes on forever. Okay, let's look at this next one. It says negative 3 minus x greater than or equal to negative 3. So one of the other things you want to keep in mind when you're working, I'm going to go down here and go underneath it. Okay, I'm going to subtract 3. Let me write it again because that may be a little confusing. Okay, I really wanted to write that on top of my, let's try that one more time. 3 minus x is greater than or equal to negative 3. Okay, we talked about this with equations, that dotted line or that solid line, however you want to draw it. Okay, we have to do the same thing to both sides. So I'm going to subtract 3 from both sides of my equation. 3 minus 3, yep, that goes away. I'm left with negative x. Negative 3 and negative 3 give me negative 6. All I did was add or subtract, so I keep the sign the same. Have to solve for x and not negative x, so I'm going to divide by negative 1. Okay, because this number that I divided by was negative, write the word flip there because you know that you have to flip. And that gives my answer x. I'm going to flip it. Equal stays there. Negative 6 divided by negative 1 is 6. And notice my answer is positive, but I still had to flip it because the operation of multiplication or division by a negative number is what causes your sign to flip. So put 0 on my number line. 6 is to the right. Put my circle. It's equals, so I'm going to close in my circle. Which way do I shade? I'm going to shade to the left because x is on the left and the arrow is pointing that way. And that's a really bad arrow, but I'm sure y'all can do better. Okay, last one. This is one we just talked about above that was a compound inequality. And when you have this compound inequality, negative 6 less than or equal to 1/2 x minus 4 less than negative 3. Okay, as I said before, you have two of them. You want to put your lines. This is like two different equations altogether. And when you do to one side, you're going to have to do to all three places. You're trying to get x by itself. So to get x by itself, I got to get rid of that 4. I did not mean to do that. So I'm going to add 4. And I have two lines, so I got to put it on each side of these lines. So negative 4 and positive 4 go away, leaving me with 1/2 x. I didn't multiply by anything, so I still have the same symbols. Negative 3 plus 4 is 1. Negative 6 and negative 4 is negative 10. Except for I didn't have anybody here telling me that that wasn't supposed to be negative 4. That was supposed to be positive 4 because I added 4 to everything. Plus 4. Negative 6 plus 4 is negative 2. And now I have 1/2 x, which is similar to what I did there. So I am going to multiply everything by 2. Everything. Negative 2 times 2 is negative 4. This is not a negative number, so I do not have to flip my signs. 1/2 times 2 is 1, leaving me with x, and 1 times 2 is 2. So this is the algebraic answer to my problem. And again, I'm going to put 0. -4, I'm going to put it a little bit further away than +2. I have a circle on both of these. Those are the numbers in my answer. -4 is equals, so I'm going to close in, put the extra work there. 2 is not. And remember, when we have these two numbers with a combined inequality, we always shade in between. Okay, if you have some problems to practice, please let me know if you have any questions. I didn't talk about it, but you can always check your answers by picking any number in this solution set. So 0 is in our solution set. Is 0 greater than -2? Yes, it is. Is 0 in between -3 and 7? Yes. Is 0, excuse me, is 0 less than -1? It's not, which is why 0 is not in the shaded region. And again, if you plug in 0, 3 minus 0 is 3. 3 is greater than or equal to -3. So 0 is in my shaded region. So each of these, you can pick any number you want to and plug it in if it's in your shaded region, and you'll have a true answer. So come see me if you have any questions. Thanks.